In this video, we're going to look at another application of transforming a Riemann sum to an integral. The limit n goes to infinity, summation I goes from 1 to n, root of n squared minus I squared divided by n squared represents an integral a to b f of x dx. What is the integral? And we also need to evaluate the integral using geometry. So to solve this, let's go back to the formula for right-hand Riemann sum. So limit n goes to infinity, I goes from 1 to n, f of xi, delta x. That's equal to the definite integral from a to b, f of x dx. And delta x, regular partitions, is b minus a, upper limit minus lower limit, divided by n. Alright, so the goal here is to rewrite the Riemann sum in such a way that delta x equals 1 over n appears inside the summation. So we do need to do some algebra. Limit n goes to infinity, I goes from 1 to n, root of n squared minus I squared divided by n squared. Alright, let's divide by n squared inside the radical, divide by n squared, and let's divide by n outside the radical, because dividing by n squared inside the radical is equivalent to dividing by n outside the radical. The reason is root of n squared is n when n is positive, and n is in fact positive because n is approaching infinity and that's a positive number. Alright, so let's simplify this. We have limit n goes to infinity, I goes from 1 to n, root of 1 minus I over n all squared divided by n. Let's simplify a bit further. Limit n goes to infinity, summation I goes from 1 to n, root of 1 minus I over n all squared times 1 over n. And this is in fact delta x right here. So we have developed delta x. And this part here is xi. So let's start with xi is equal to I over n. I goes from 1 to all the way to n. X1 is 1 over n. X2 is 2 over n, plugging I equals 2. X3 is 3 over n. Xi is I over n. Xn is n over n. That's equal to 1, and that's the last x value, that is b. So how do we find a? Well, there's two ways to do it. The first method is more rigorous, and basically we say a is equal to, start with x1 and subtract delta x. And that's going to give us 1 over n minus 1 over n. This part is x1, and this part is delta x. And that difference is just 0. So a is 0. Another way of finding a is a memory tool that you can use. Take the limit n goes to infinity of x1, which is limit as n goes to infinity of 1 over n, which is 0. And that's a. A is 0. Both methods are acceptable. The first method is more mathematically rigorous. The second method is more of a memory tool. Alright, so we now have all the pieces of the puzzle. We have a is equal to 0. B is equal to 1. We have f of xi is equal to root of 1 minus xi squared. And that means the function f of x that we're going to use for our definite integral is root of 1 minus x squared. So delta x, by definition, is b minus a divided by n. B is equal to 1, a is 0, divided by n, that's 1 over n. So we're now in a position to transform the Riemann sum to an integral. So limit n goes to infinity. The question we had was I goes from 1 to n, root of n squared minus I squared divided by n squared. We did some algebra and we produced limit n goes to infinity. I goes from 1 to n, root of 1 minus I over n all squared times 1 over n, and that is the definite integral from 0 to 1, root of 1 minus x squared dx. So we were basically able to transform the Riemann sum into a definite integral. And the definite integral that we have is 0 to 1 root of 1 minus x squared dx. Our goal in the second part of the question is to actually solve this. So how do we go about doing this? You will notice this function f of x is actually the top half of a circle of radius 1 with a center at the origin. We're going to prove that. So f of x is root of 1 minus x squared. All right, so we have 0 to 1 root of 1 minus x squared, and we want to evaluate this using geometry. Let's call this y. Y is equal to root of 1 minus x squared. Square both sides. We get y squared is equal to root of 1 minus x squared all squared. That's equal to 1 minus x squared. Now bring the minus x squared to the left-hand side, and we will get x squared plus y squared is equal to 1. This is the equation of a circle with radius 1, and center at the origin. So if we draw a diagram, here's the top half of a circle, which is y is equal to root of 1 minus x squared. And we're integrating from 0 to 1. So we're finding the shaded area of a quarter of a circle. So the integral from 0 to 1 root of 1 minus x squared dx is equal to pi times radius. The radius is 1, so that's pi times 1 squared divided by 4 because we have a quarter of a circle. So that's pi over 4. And this is the actual value of the definite integral. So basically, we can say that the limit as n goes to infinity, summation I goes from 1 to n, root of n squared minus I squared divided by n squared is equal to the integral from 0 to 1 root of 1 minus x squared dx. And that was the first part of the question where we transformed the Riemann sum into a definite integral. And the second part of the question, we actually evaluated the definite integral. So the integral from 0 to 1 root 1 minus x squared dx, that's equal to 1/4 of a circle of radius 1. So that's going to be pi over 4. All right, thanks.